note down questions you have about the other presenters. So that we have a lively discussion. It worked actually out surprisingly well in the last session. All right. Yes, now kind of the session started, and so I'm very happy to welcome the authors to this session. We have a rich bouquet of research to present, will be presented to us. And the first one to present is Rashina Hoda from Monash University in Melbourne, and she will talk about a journal first presentation. She will talk about socio-technical grounded theory for software engineering. Thank you very much, and welcome, Rashina. I'm looking forward to your presentation.
Thanks, Yvonne. Hello, everybody. As Yvonne said, I am Rashina Hoda from Monash University, and I'm going to be talking about socio-technical grounded theory for software engineering, or STGT for short. And this is a journal first presentation based on the IEEE Transactions on Software Engineering paper published last year. Cool. So STGT is basically a socio-technical version of the traditional grounded theory research methods. So what you see on your right is a timeline of how grounded theory started off in 1967 with the classic Glasserian grounded theory, which was emergent in nature. And then we got introduced to the Strauss-Corbinian theory of grounded theory in 1990. This was followed by a constructivist view of doing the same thing in 2006 by Kathy Chamas. And then I've, of course, as I said, introduced socio-technical grounded theory last year. So you may be wondering like what it is and when to use it. So STGT is best used for empirical qualitative research studies that involve people and or a consideration of the human and social aspects in the context of technology, basically, for development or for technology development and use. Now, this technology can be technology that we know of in software engineering or artificial intelligence, in human-computer interaction, in information systems, e-health, e-banking, or basically anything software plus any domain, right? These days, almost everything has a component of technology in it. So that's when you would want to use STGT. Now, why do we need this? Why were we not happy with the traditional grounded theory methods? So my big proposition here, of course, is that socio-technical research and conducting socio-technical research needs socio-technical research methods. So just me saying that did not like satisfy my reviewers. So I had to go and then describe to them what I mean by ST in that STGT acronym. So socio-technical, then I went ahead and described the entire research framework, which is this. So I'm then going to describe the phenomena, which is a socio-technical phenomena, the domain and actors, researchers, data tools, and techniques. So bear with me. Socio-technical phenomena essentially is the idea, or topic is essentially the idea where human and technological interactions are so tightly coupled that studying one without studying the other is kind of making for an incomplete investigation and understanding. So give you an analogy, think about like, generally we look at the world in 3D for all practical purposes. Now we can choose to kind of, cover one eye and look at it in 2D, and that's fine, but we acknowledge that we're looking at it in 2D. So when we talk about ST, we're basically saying, we can cover one eye and say, all right, I'm only going to look at the social side. I'm not going to look at the technical, or I'm only going to look at the technical side. I'm not going to look at the social. But the reality is, you have to uncover both your eyes and see the fact that it is truly and intrinsically socio-technical. That is the reality of the 3D sort of analogy that I used. And that's what I'm sort of proposing that we do. So this then is the socio-technical domain, is sort of software engineering, computer science, and so on, as I said, and we can study software engineers, data scientists, software users, and so on. A socio-technical researcher then has a number of different sort of skill sets. I can't go into the details, they're in the paper for you. And we will be sort of using the traditional methods, but also the modern methods such as data mining and NLP and sentiment analysis and so on. Okay, so it is one method and it offers sort of flexibility. It has the best of both traditional as well as modern methods. Gosh, this 4 minutes is going really fast. And this here is the method. I'm not, again, going to be able to go into the details, but the basic idea is there's a basic stage and there's a advanced stage. So if you do just the basic stage, you're doing SDGT for data analysis. But if you do the entire thing, then that is SDGT, the full study, and you're able to sort of define and create theories from there. So as I said, the basic stage then allows the researcher to learn and experience, and it's an easy entry point. But if it's not your cup of tea, then you can exit at the basic stage and just with the descriptive findings, which can be published, and you don't have to go ahead. But if it is your cup of tea, and these are some examples of papers that actually do that, but if it is your cup of tea, then you go ahead and do the entire advanced stage and to create mature theories from there. There's also a nuanced evaluation framework. Again, no time to go into that, I'm afraid, but I can answer questions about that. So I do encourage you to read the paper, which is Socio-Technical Grounded Theory of Software Engineering. Watch out for the book, which I am still writing, and get in touch with me on these venues, which is my email, on Twitter, if you're on Twitter. And you can find the preprint as well as all the videos of the technical briefings and so on my website /SDGT. Phew, done.
Thank you very much. And thank you for making talking about such a complex topic in such a short time. We have the next presenter now. It's Huri Kalashade. I hope I don't violate your name. And how are diverse end user and human-centric issues discussed on GitHub?
Sorry, I was talking while I was on mute. Thanks a lot for the introduction, and hi everybody. Thanks for joining this presentation. My name is Huri Khalaizadeh. I'm from Human Eyes Lab at Monash University in Melbourne, Australia, and I'm going to talk about our work on identifying how diverse end-user human-centric issues are discussed on GitHub. Software systems aim to deliver efficient and satisfactory solutions in order to fulfill the expectations of their diverse users. But there are lots of problems with end users having issues because of the lack and addressing and proper consideration of their specific characteristics, limitations, and abilities, such as their age and gender, physical and mental impairments, and so on. And developers' discussions are known to be a major factor in deciding how a system evolves, and they also include information beyond how a system actually works. And online software repositories such as GitHub attract a lot of discussions between developers on different topics and include information about the issues that they face during software development process and how they react to these issues. In this slide, you can see an example of an issue on GitHub, which has a title and then has several comments. And this is related to an issue that a user who's dyslexic has with the system, and the user needs some options such as the ability to increase font size, line height, and fonts. And this is actually followed by another developer comment saying that I'm not sure if I agree with you. Which shows that developers are not necessarily aware and agree with the issues that users face. To be able to understand how human-centric issues are currently discussed by developers in popular software repositories, in this work we identified and categorized the human-centric issues that are discussed by developers in GitHub. We focused on a diverse range of end-user-based projects with different sizes and domains and types of users in order to increase the chance of identifying human-centric issues. We collected all the issue comments in 12 diverse projects and took a representative set of 1,691 issue comments for our manual analysis. We then completed the study in 2 phases with 2 analyzers in the first phase and then 3 in the second phase to come up with a taxonomy and to be able to label human-centric issues in different categories. We finally categorized the human-centric issues into 8 categories: inclusiveness, privacy and security, compatibility, location and language, preference, satisfaction, emotional aspects, and accessibility. We found that a wide variety of human-centric issues are discussed in different GitHub repositories. Some of the human-centric issues are discussed more commonly, such as privacy, satisfaction, and user preferences. And we found that there is a very limited discussion of accessibility, emotional aspects, and so on. We also found that human-centric issues are different across different projects, and unlike our expectation, projects designed for challenge end users such as visually impaired and dyslexic users and the ones with large-scale end users such as Firefox have very limited discussions of human-centric issues, specifically in accessibility and inclusiveness categories. And based on that, we provided some implications and recommendations for the other researchers and practitioners. We found that there is no structured way of reporting and addressing most human-centric issues on GitHub, and we believe that there is a need for more human-centric issue reporting and follow-up process and tools. In addition to this, we recommend that awareness of human-centric issues, training the developers, increasing their general awareness of the human-centric issues can help incorporating and reporting human-centric issues more effectively. We are extending this work by looking at not only developers' discussions, but also the issues that end users report through app reviews on different App Store and Google Play stores. And we also built a more comprehensive set of human-centric issues. We have also developed a smart tool to automatically detect such human-centric issues and are looking for practitioners' feedback on them. Thanks a lot for listening to my talk. Please reach out if you have any feedback, comments, and questions.
Thank you very much. Yes, I think that's about time to have research on human-centered issues on GitHub. I think that is a long-awaited piece of research. The next presenter is Stefano Lambiase. And good fences make good. That's the title of the talk, and it's about collaboration in distributed software engineering.
Okay, thanks. Hello there, I am Stefano Lambiase, and I will present our work about the impact of cultural and geographical dispersions on community smell. Allow me to start with the context and the objective of our study. It's important to know, and most of you already know, that software development has never been so distributed. And this led to the emergence of new social and human factors, like the cultural and geographical one, that could impact communication and collaboration activity in software development community. Now, also other works have already studied the relationship between these two factors, but in order to provide tools to manage this impact, recalling what Peter Drucker say, namely, if you can't measure it, you can't manage it, we decided to move from the qualitative field to the quantitative one, studying how cultural and geographical dispersion affect community smells in software communities. Now, allow me to present the ingredients of our recipe. First of all, most of you already know the concept of community smells that we have used in our work to represent quantitatively collaboration and communication patterns. And for that reason, let's focus on the concept of cultural and geographical dispersion. We define cultural dispersion of a development community as the degree to which developers form a community with different cultural attitude. And on the other side, we define geographical dispersion as the degree to which its member, the member of the community, work from different and distributed places in the world. So, just for example, if you have a development team that is working, which members are all working in the same office, but that grew up in different places all around the world, you have a low level of geographical dispersion, but a high level of cultural dispersion. Now, let's move to the methodology and the results of our study. We're starting from two research questions. The first one, to what extent are open source communities culturally and geographically dispersed? And the second one, to what extent do cultural and geographical dispersion within team influence the number of community smells? To answer this research question, we implemented a quantitative methodology, a quantitative study. We used two data sets, provided socio-technical metrics about various communities on the GitHub platform. For each one of these communities, we computed the cultural and geographical dispersion metric, and we used graphical statistics to answer the first research question, and we built 4 regression models to answer the second research question. Regarding the first, our statistical analysis revealed that GitHub presents community with both low and high geographical dispersion values, and that GitHub is not extremely culturally dispersed as one could expect. For our second research question, we built 4 regression models, decided to represent the communication and collaboration patterns in software community using 4 categories of community smells, namely organizational silo, black cloud, lone wolf, and radio silence. And we studied the relationship between the dispersion metrics and other control factors on the emergence of such community smells. Our study revealed that cultural dispersion is relevant for the emergence of radio silence and lone wolf effect, and that geographical dispersion is relevant for all the smells except lone wolf. More interestingly, we demonstrated that such an influence is not only positive or negative, both for different and in the same smells. So, to conclude, allow me to recall the title of our paper. So, good fences make good neighbors. Our study revealed that cultural and geographical dispersion impact communication and collaboration activities, but yet not necessarily in a negative fashion. So the answer is it depends. Thanks for your attention. This ends my presentation.
Thank you very much. Yes, so we have our next presenter is Annika Wolf, and she talks about open data inclusion through narrative approaches. So we have a pattern here going on open source and open data and how to make use of that.
Okay, thanks for the introduction. Yeah, so I'm Annika Wolf. My co-authors are Natasha Tilowski and Tanvi Hassan, who made this playful slide template for me. I'm going to start with a brief synopsis of the talk, which is also going to be very short, so it's going to cover a very high level of the ideas. And it's about how open data obviously is intended to be open and available to everybody, but that in fact is not the reality and not everyone can use it. And of course, there are many barriers against its use, some of which I will go into, but a lot which can be found from the paper also. And a little bit about what they are, and then also how to overcome them and to make data more inclusive using narrative structuring as a possible solution. So these are just a few of the barriers that I mentioned. So one barrier is that open data often is collected and in quite a distant past, according to potentially biased instructions or procedures or things that may introduce these kind of hidden imperfections into the data. And if you're close to the data collection, you understand the limitations. But if you come to the data down the line, you may not really know what these problems are or what the limitations were and what decisions were made about what to include, what not to include. And of course, this creates issues if you think the data will tell you one thing and actually there's something that you don't know about it that means that your results will be skewed. And this information is very often not made available alongside the open data, so people can't really judge how good it is. Another thing which is quite a big issue is that the open data portals, the search isn't necessarily great, and that's particularly true for people who are not very expert in using data. Novices, for example, use different search strategies and may favor using the search box over using the filters, and that leads to different results for them than it would for somebody who's more good at searching or has more expertise in searching for the data. And then if you find the data, then often it's really hard to judge your relevancy because whereas on Google, you get quite good information back from your search in the form of a teaser. To understand what the data set's really about often requires several steps. And there's no really consistent way of creating data teasers that give key information that will help you to judge relevancy. And the other thing is they don't really support serendipitous search. So you tend to find what you're looking for, but you don't find, maybe there's something that's related to the questions that you have and want to answer, but it's not necessarily the data that you think, and you can't find that easily. And then the other thing is that, especially for people that don't have technical skills or haven't been taught technical skills, they might find it difficult to navigate through all of these steps. And data is a really important resource, particularly for communities, to empower them to identify problems and they can get a lot of benefit from it, but they often can't utilize it. So the idea is to use narratives because people love telling stories and are inherently narrative thinkers. And this is a conceptual framework that has been developed to explore how narratives can help to solve this problem. So narratives can be formally described, for example, in terms of the setting, the time and place in which they occur, types of themes they cover, and the characters. And of course, these descriptions can also be applied to data sets, and we can identify data events, so events when data was created, that tell us something about what was happening at that time, what was included, what wasn't included, what the data set covers, and so forth. And stories are made of these events, and these events are structured into things which are somehow similar, so they have overlap. So a story has an overlap, for example, in having events that occur in a similar place and time about the same sorts of people and related to the same sorts of things. And you can filter out things that happen in the same time and place that maybe aren't relevant because they don't involve the characters or entities that you're talking about, essentially. So you can use these principles to group data sets into things that may be narratively similar, change the scope of this, and then eventually tell a story about it, deciding which media you're going to use. So the details of the framework are available from the paper, of course. But to make it happen, there's a lot to think about. So, for example, we need better solutions for describing data, knowing how to merge data, how to calculate narrative proximity based on these principles. And from this, we can start to build recommenders. And then these recommenders might support more naturalistic search, for example, natural language search, and better data discovery through the recommenders, more serendipitous discovery. And then just to sort of finish, not a lot of time to go through these, but there's a couple of examples of what this could look like. So on the left-hand side is an idea of applying these principles to creating quite playful data teasers, especially for children, in the form of data comics. And on the right is a data explorer, which shows how these different entities might be used to help search. And more details again from the paper, but for now, that's it. Thank you very much.
Thank you. This is really amazing. Before we go into the next presenter, I would invite everybody to also put questions into the chat. I was bad in the last session to take that, but I'm observing the chat as well and will call on you. Our next presenter is Hideaki Hatta, and he will talk about GitHub sponsors and exploring a new way of contributing in social software, in open source software.
Thank you for the introduction. I'm Hideaki Hatta from Shinshu University, Japan. So in this paper, we studied GitHub sponsors, which allow the developer community to financially support people and organizations directly on GitHub. The open source software projects are often affected by economic challenges, and soliciting donation is a common means of obtaining funding for OSS projects. However, many OSS maintainers and developers do not generate enough income to sustain the OSS project. In May 2019, GitHub introduced GitHub Sponsors, a service which allows OSS developers to accept donations from other GitHub users. While most of the OSS donation services in the past have targeted projects, GitHub Sponsors is unique in that it allows users to donate to individual OSS developers. GitHub advertises this service as a new way to contribute to open source. So in this work, we conduct exploratory study of GitHub Sponsors. The main goal of this study is to gain insight into the use of GitHub Sponsors among individuals. Based on this goal, we constructed these 3 main research questions and sub-research questions to guide our study. Since there's no direct way to get the users who participate in GitHub Sponsors, we first examine repositories to get a list of contributing GitHub users from all contributors to the more than 1. We identified sponsored developers and non-sponsored developers who are seeking sponsorship but have not yet obtained it, as well as individual sponsors. Let's see some of the results. We consider the most common primary language in the repositories to which each developer has contributed to be that developer's primary language. As seen in the table on the left, we found that JavaScript, Python, and PHP are the most frequent primary languages for GitHub-sponsored participants. As we can see in the violin plots on the number of contributing repositories and the highest number of stars in the contributing repositories shown on the right, sponsored developers are more active in popular projects compared to non-sponsored developers. When we draw similar violin plots for sponsors, we found that the sponsors were also active OSS developers. Of the approximately 4,000 sponsored developers, 22% are also sponsors, suggesting that developers are sponsoring each other. Therefore, as shown in the figure on the right, we build a network with developers as nodes and sponsorship as edges. In this network, we can see that developers of the same major programming languages, such as JavaScript, PHP, C#, and Ruby, form clusters. In particular, we found that PHP developers form the largest clusters and have a strong social network of donations through GitHub sponsors. We surveyed developers on important factors to consider when deciding who to sponsor. As expected, being a major contributor to an important OSS project was a very important criterion. Then, in terms of the criterion of inspirational, the majority of responses were positive. Because of the individual sponsorship, personal attractiveness seemed to be important. We analyzed the responses of the reasons why developers sponsor other OSS developers. We found that having dependencies on the code written by the receivers of the sponsorship and recognition, then appreciation are the most frequently mentioned reasons for all defined roles of OSS developers. Finally, I'd like to share some implications and future challenges from this study. While donating to OSS open source project is not necessarily new, our study confirmed that some sponsors do indeed see sponsorship as an alternative to contributing code. Then a unique feature of GitHub Sponsors is its focus on enabling sponsorship of individual developers rather than entire project. As a side effect of this, an individual developer's social network is an important determinant of whether or not they are able to attract funding. While we only examine sponsorship by individual developers, organization sponsorship is also an important aspect and should be analyzed in future studies. Then it is also interesting future research to investigate how sponsorship to individuals affect the sustainability of OSS project. That's all. Thank you.
Thank you very much. And now we have our last presenter, that is Christoph Gothe, and he will talk about big data equals big insights and looking into operationalizing Brooks law in the massive GitHub data sets.
Great. Thank you very much for this introduction. Indeed, our title of the paper that we wrote is Big Data equals Big Insights, and that's exactly the question we're aiming to ask by specifically looking at operationalizing Brooks' Law in a massive GitHub data set. My name is Christoph Gothe. I'm a postdoctoral researcher at the Chair of Systems Design at ETH Zurich. So let's start with reconsidering what Brooks' Law is. As we all know, Brooks' Law basically states that adding manpower or human resources to a late software project makes it even later. And one of the reasons that Brooks talks about in his book is a communication overhead, which increases in larger teams. That said, studying this communication overhead, we have recent studies that on the one hand find that their productivity of larger teams increases, and the other studies find that productivity decreases with this team size. In other words, using similar data and performing very similar analyses, different studies find contradicting results, which we argue should worry us. So the aim of this talk is to figure out, well, can we somehow combine the two results from these different publications? So is there an optimal team size? And if not, well, what causes these contradicting results in the data? And in order to do so, we basically look at 4 challenges in the analysis of big data. One would be big quality, data quality. So if we look at the projects on GitHub, which projects are actually suitable to study our research question. Things like population validity. Let's say we have 100,000 projects. If we cannot study all of them at once, how do we select projects from these 100,000 without introducing a bias? There is construct validity. Obviously, in order to study this relationship, we need to operationalize productivity and team size. And finally, omitted variable bias. There might be a lot of other factors also influencing this relationship. And in our work, we first develop a curated data set to study productivity in open source software teams, which we also make publicly available. We compare multiple different operationalizations specifically for productivity. And finally, we also control for the interaction structure of these teams. Unfortunately, in 5 minutes, I cannot go into the details of this, but let's look at the results of our findings. So the general finding is a negative relationship between productivity and team size. Effectively, we find that by doubling the team size, the individual productivity by a single developer goes down by roughly 25%. However, if we look on the right-hand side, we fitted a linear regression model and a quadratic regression model similar to what the previous papers did to our data set. And effectively, we find that the quadratic model fits this data set better and suggests an optimal team size for these open source projects at around 10 to 20 team members. However, if you look at the large variance that you can already see in the points on the right-hand side, a regression model that just looks at team size and productivity has very low explanatory power. And by controlling for the interaction structure in our project, we can increase that significantly to roughly 50%. The problem is, if we do so, well, this productivity increase that we see here in the beginning actually disappears. So we asked ourselves, well, where did it go? And this is what we aim to answer by this question. If we look at the interaction structure, one of the key variables here is the in degree, which basically tells us how many unique interaction partner does a member of this team have. And if we look at the top right-hand side, we see these lines with a negative slope, and the different lines going up in overall productivity, which is shown on the y-axis, are the lines with additional team members that I interact with. At the same time, if we look at the bottom right, the amount of unique team members actually increases with the team size that we're studying. So in essence, we find that both the interaction partners have a positive relationship with productivity and team size. Another fact with studying GitHub is that most teams on GitHub are actually small. So if you analyze the entirety of GitHub or you sample projects with a random distribution, you'll end up mostly studying small projects, where this increase in the in degree or the unique interaction partners is actually the largest. And so if you focus on small teams and not control for the coordination structure, you can actually have a special case of Simpson's paradox, increasing the productivity across these different in degree bands here, which leads to an erroneous positive relationship between the team size and the in degree. The team size and the productivity. So which lessons did we learn? First, the lesson is, well, big data, studying the entirety of GitHub, for example, does not automatically yield to big insights. There are a bunch of challenges with big data that we need to consider, because otherwise we can get erroneous results here. In terms of productivity, we find an overall negative relationship between productivity and team size, but we showed some evidence that adding members to small teams can increase their individual productivity. I hope this talk made you interested in reading the full paper, which I've linked here on the right-hand side. There's also a reproducibility package and, as promised, the dataset available. And if you want to crawl your own dataset, similar to the one that we have, we also published a open source Python package that you can use in order to crawl fine-grained data from GitHub repositories. Thank you very much for your attention.
Yes, thank you. Thank all the authors for the rich bouquet of research we have here. Yes, does any questions from the audience? I had actually it was actually interesting to see a discussion between Rashina and Tori. What was your research method and what would have been a different approach to, and what might be a result if you not only apply quantitative but also qualitative methods on the GitHub thing. So this is a question to both of you. More or less, to Huri, have you considered looking into qualitative methods and like Rashina is standing for? And a second question to Rashina: how would you go about to apply grounded theory on such data? So Huri, you go first.
Yeah, I can probably go first. So in terms of how to use socio-technical grounded theory, we've already used that in some of our projects. We've done lots of like interviews, and we've used socio-technical grounded theory to be able to analyze data. And I think in terms of using that for GitHub projects, the problem is that there is a limited amount of data that we can find from GitHub. So it doesn't give us the depth that we are looking for. But we've used that for interviews. And the good thing about interviews is that we can revise the questions, interviews, and we can just do that until we get to the point that we have like saturated data and we can easily analyze that. So I think Rashina can add to that, but we're definitely using like working together on different applications using different methods that we're working on.
Cool. Thanks for that question, Yvonne. For the Huri and I work at the same lab. We're the Humanize lab. So it's inevitable that we've been working together and applying SDGD in some of our projects. So, and that was a great answer, Huri. So just filling up on the bit that Yvonne asked me, I think we haven't done this yet, but the way I see this being used, so SDGD for data that is from GitHub, one of the ways that we can use it is to actually understand what it is that we need to study first, because that can be a big problem. So for instance, if I take an example of if you wanted to study what project managers do on agile projects. So one of the issues with looking at GitHub is you first need a corpus that has been identified to be using agile project management, right? And then you need to identify the data in there and projects and wiki, the comments and so on that are specifically to do with the project manager's role. So in order to get to that point where it's a reliable labeling system, for instance, you can pick out through manual means of grounded theory, try to identify which of the sort of projects, for example, and which types of comments that we're looking at and so on, and to then build up that classification system based on the initial SDGD sort of approach, manual approach. And when that is looking robust, then we can scale that in the usual ways that we do with mining software repositories and so on. So that's one way. with the current sort of capabilities that we have. A future vision, of course, that I also share in the paper is, because we have these advances in natural language processing, that at some stage in the future, I don't know if I'll be here to see it, but that even something as super, detailed and rigorous as STGT can actually be automated. And when it is automated, then it can be scaled, obviously. So that's a future vision. But I'm hopeful, because the way NLP and so on is advancing these days, we can see it someday.
Yes, thank you very much for the enlightening answers. Yes, so then we had this. I also was very enthused by Annika's presentation of narratives, use of narratives, and I was looking for. Can you tell a bit about an example how you can actually use narratives to kind of make open data accessible?
Well, that's a very, I mean, obviously the talk only went into a very kind of broad overview of what could be done, but we've actually been looking at many different examples where narrative can support it. And the reason, as I briefly mentioned in the talk, why this is such a good approach is that narratives are so natural to people, and anything can be broken down into these kind of narrative components and then built up again in different approaches. So, for example, if we're just talking about the data teasers, and I showed briefly the kind of ones that have been done as a data comic, we've got different layers of story there. So on the one hand, we have narrative principles that help to guide what we should include in a data teaser that would be important to include. So, the data teaser should at the very least, cover the time and the date. It should mention the theme. It should talk about the characters. And by characters in this sense, I don't mean, necessarily story attributes of the data set that really define somehow what the data is about. So for example, with the one I showed, it was about water quality, and the characters in that case were phosphorus and chlorophyll, which are two important factors in assessing water quality. And you can follow different characters, in a story, and the data comics are just one way of telling that in a very concise way that will give you a quick introduction. So one is making the kind of data teasers and using narrative principles, and then the other aspect is how you tell that story to an audience, what narrative, what story form you choose, what media you choose, whether it's a graph or whether it's actually just a comic, or if it's a documentary. Some people have been looking at films and these things for introducing data. So it's really, if any aspect you look at from the process of thinking about data, describing data, structuring data into, trying to find data that's similar, then telling the story through data and relating it to your problem, I could look at every aspect of that process and give you some explanation of how the narrative approach would be able to support it. So I can't answer all of that now, but hopefully it's given you some idea.
Thank you very much. I think I have a problem with the chat because it doesn't move. So if there's chat messages, maybe Julia, you could help me to give indication whether there's questions in the chat. Otherwise, I think Christoph had a question to Huri, and would you like to?
Yeah, I can take the first two questions that are related to me, if that's fine. So there was a question from Christoph asking whether we saw any differences between bugs and feature requests related to human-centric issues. We didn't actually look into that in this paper. We looked into GitHub comments only, but we have another paper where we looked into bugs and feature requests reported on COVID-19 applications. I've sent a link to the presentation. Actually found really interesting findings. We had interesting findings in that research, and for example, for different feature requests, there were human-centric aspects, mostly in COVID-19 applications related to the location where the users were accessing the application or the languages. For example, some of the COVID-19 applications were designed to be used in Europe, but then they were only being accessible in different countries, and people who were traveling for work in different countries were facing issues, and they were asking lots of, they were sending lots of feature requests through different app reviews. Or, for example, in terms of privacy concerns that they had, people had like different privacy concerns based on their like characteristics. It's not something that is technical. It's based on their characteristics. They were reporting lots of privacy issues, asking, or in terms of user experiences, or some of the bugs that they were having were related to the location they were trying to access the application from. So that's been discussed in more details in that paper. And there's also another question from Miguel asking whether we observed any differences from one repository to another one. Again, thanks for the question, Miguel. We again didn't look into that work here, but then we have an extended version of this work where we looked into app reviews as well as issue comments. So here in issue comments, we also observed differences. Like we didn't see many human-centric issues reported in Firefox or discussed in Firefox, for example. And then Firefox is a very large-scale application. We were expecting to see lots of human-centric issues, but in fact, we didn't see. And then we looked into the app reviews for the same application, and we found lots and lots of human-centric issues reported by the users. So something that we found in the extended version was that we didn't find many issue comments discussed by developers, but then in the extended version, we found lots of app reviews reported by the users that are discussing human-centric aspects. And something interesting we found was that for some of the applications, if there are not many issue comments discussed by the developers, then there are lots of app reviews reported by the users, and vice versa. So if something's being comprehensively discussed by developers and we didn't see many issue comments and many app reviews reported discussing or asking for the same human-centric aspect. So that's again in an extended version of this paper, but yeah, we found some interesting things there, and hopefully I answered the questions.
Yeah. Thank you very much. The whole chat disappeared from my chat list. So,
okay, we have a question from Christoph to Hideaki. I don't know if Christoph, you want to read your question, or I can do this.
Sure, I can read it. So essentially, when I participated in MSR last year, we had a very interesting discussion in one of the coffee breaks where we found out that, well, most of the libraries that are published at MSR are only maintained for a couple of years, because in essence, the authors of these, or these researchers, cannot afford to have people working on these libraries and maintaining them for a long period of time, as you're only paid for the initial publication, or you only get grant money for the initial publication of the paper. How do you see, or did you get any evidence that sponsorship from GitHub helps in this regard at all in your data, or do you have any expectation in that regard?
Yeah. Thank you for the thank you for the question. So short answer should be I think yes. So we haven't focused on those software library from academia, but we have our research question 3.2 explicitly asked what's the impact of getting sponsorship or not getting sponsorship. So there are many sponsors mentioned. Motivation is a impact of getting sponsorship. So maybe not the amount of the donation is not a big matter, but getting sponsor from others should be a big motivation. Then, so for impact of not getting sponsorship, it is of course limited effort and low quality or something. So yeah, getting sponsorship should be changing something. Thank you.
Okay, we have another question for Hideaki as well. Tapajit asks, do you have any insight into the sponsors' company affiliations?
Thank you. This is a very interesting question. Then, so we haven't investigated those affiliations. Actually, most of those GitHub users don't show affiliation. Then some sponsors do not show their account as well. So we don't know the overall percentage of those company or affiliations. But as far as I investigated, I think there's a variety of sponsors. So their sponsors come from different companies. Some are students, some are of course come from industry. But I see there's a variety. So yeah, this is interesting. Thank you.
Okay, I see in the chat that Alessio and Rashina engaged in a little discussion. Apart from that, we haven't got any more questions in the chat. So maybe if Rashina wants to share her insights on the question made by Alessio.
Sure. So Alessio is picking up on something that I'm actually interested to know more about. So he's talking about a research context where there were political figures involved and apparently having trouble getting people to talk, which I can quite well imagine might happen. So in this case, I think I was pointing out the fact that you can obviously look to other sources rather than just interviews. And in this particular case, it sounds like when you have politicians, for instance, they inevitably end up generating a lot of public resources, whether it's their interviews online, for news channels, for media, when they have made public statements, or any of their policy documents. All of that, it can be, data and resources. Now, from an ethical perspective, I was just finishing up that comment. From an ethical perspective, it still makes sense to try and gain I guess, approval from their office, so the office of that politician, to make use of that data for research. Again, you might run into problems of getting that approval, but ideally we should try and get that approval even if it is publicly available. That's just ethical research.
Thank you. Thank you, everybody. I have a question for Stefano, because I was wondering about what are the recommendations, because you identified now kind of how disparity actually affects collaboration. So what are there any recommendations you can do based on your research? And they would be hypotheses that would have to be investigated in the future.
Yes, very interesting. Can you hear me? Yes. Okay. Yes, very interesting question. From a recommendation perspective, I think that we should provide managers and software project managers with tools to compute and calculate the cultural and geographical dispersion value of their team. Because, for example, we have seen that, for example, in the case of organizational silo, having team members located nearby can lead to the emergence of the formation of various sub-communities, so to the emergence of organizational silo effect. So maybe having a community more geolocated in the same place could mitigate the emergence of such an effect. But also in the case of individualism versus collectivism, we found that encourage the individualism behavior. So do not try to integrate individualistic people in the team, could lead to the improve of, for example, productivity related to the work of Christophe, if I correctly remember, about the productivity, because we have seen that having lone wolf or individual peoples that could work in their individual behavior improve productivity in terms of team productivity. So this is my recommendation specifically. This is the most important, in my opinion, finding of our paper.
Maybe if I can comment on that, because there was also a question by Alexander that basically went in the same direction. I've done a bit of research in the last years for my PhD thesis on exactly these lone wolves, because we call them star-shaped networks in open source communities, where there's basically one person in the middle of this star that is then aiming to basically control for the rest of the team, or organize the remainder of the team. And we have one study that we're going to publish soon, hopefully, where we actually find that there's a significant trade-off between the productivity that you can achieve by forming the teams in this kind of structure and the resilience that these teams have against shocks where, for example, like in the Gentoo project, this central developer that is in the core of this project actually leaves at some point, and then the project has to reorganize to get to that, to regain their functionality. So while the lone wolves are actually helpful in terms of productivity, they might actually be a huge risk for the team in terms of other aspects of productivity or performance of these teams, which I think are very interesting to explore as well.
Yvonne, you're muted.
Thank you. Is any other questions? If not, I think thank you very much for the presentation, and thank you very much for the engaged discussion. And
Sorry, do we have? Sorry, Yvonne. Do we have time? I had a quick one for Stefano.
yes, we have time, another 4 minutes. So you're welcome.
Sorry. So, Stefano, this is fascinating, the use of Hofstede and so on for understanding different cultures in different countries. I was just wondering, what is the state of the art with regards to, how cultures keep shifting across time and space with new generations coming in and displaying new values? Is there anything in that regard that, the Hofstede is old now?
Yes. Thanks for your question. Undoubtedly, Hofstede is in a certain way old, because the idea was to assign to each country globally a set of values that do not change during the time. So to manage the cultural shift, or maybe the cultural differences in time, I think that one possibility is to update Hofstede in the time. So we have to recompute all the Hofstede metrics for all the country to have the values up to date. But maybe we have to shift our attention not to culture of nations, but culture of team. So we need to move our attention to the community, the software development community, analyzing in which way, for example, managers consider some cultural related behavior. For example, it could be interesting to study if having a manager that is more, let me say, friendly to inclusiveness or other aspect has an impact on the team that he manages. Because if this is the case, analyzing the way managers are culturally oriented, we can determine in which way the team are culturally located in the spectrum. So I think that these are the only two possibilities, but maybe other idea could be welcome.
No, I agree. Sorry, go on, you want?
I think there's a bigger discussion behind that, and that is how do we relate to culture as a concept. And I think I think we had a question or discussion on that in the previous session where Lutz shared his concept, and I think maybe there's something that we might to look into in the future, into understanding culture in a different way.
Yes.
There's another question for you that goes into the same direction in the chat by Miguel. What about the huge diversity within each country? What that framework is putting all people from the same country in the same bucket, which is far from accurate. And as a Hofstede has been discussed quite a bit in the